Welcome, friends. I'm so glad you're here. Whether you're drifting towards sleep, unwinding after a long day, or simply looking for a quiet companion, you've found the right place. Before we begin, I'd love to know, where in the world are you listening from? Perhaps you're wrapped in a blanket sitting by a softly lit window, or resting somewhere under an open sky. Wherever you are, I hope you're warm, comfortable, and ready to wander with me into a quiet idea that the sun, the planets, and this small world of water and stone all move inside a vast, softly lit cavity in the galaxy, a low-density room in the interstellar medium that astronomers call the local bubble. If you find peace or curiosity in these gentle stories, please consider liking the video, subscribing to the channel, or sharing it with someone who might need a moment of stillness too. And to those who've already joined along, thank you. He begins where the light is thinnest. Around the solar system, the Milky Way is not uniform fog, but a patchwork of clouds, filaments, and evacuated spaces. The accepted fact sits at the centre, and does not need raising. The Sun presently resides within an extended cavity of unusually tenuous gas and dust, hundreds of light years across its interior, warm by interstellar standards, and its shell traced by dust and young stars. Neutral hydrogen is sparse here. Scattered soft X-rays, faint radio lines, and maps made from the reddening of starlight outline the cavity into an irregular egg-like shape set in the Orion Cygnus arm of the galaxy. The image he holds is quiet, not a hole torn in a wall, but a region swept clean by energy and time, a room with diaphanous air, whose boundaries are not edges, but gradients, where density drops and rises the way twilight deepens and then yields. The galaxy makes such rooms the way weather makes clearings. Clusters of massive stars live briefly and die with force. Winds and supernovae push on the surrounding medium, gathering shells, emptying interiors, and building a rind where compression invites chemistry. In that slow pressure, dust grains meet molecules form, and later stars arrive along the walls. He keeps it even. The local bubble is one of many. It is not the largest and not the brightest, it is only the one we happen to inhabit. A lesser-known detail moves past like a thin current of air within the bubble's poor gas, a warm, partially ionized wisp, called the local interstellar cloud, flows past the Sun. And because helium is neutral and honest to gravity, the solar motion focuses interstellar helium atoms into a faint downstream cone that spacecraft can measure directly. The cone is not a spectacle, it is numerical comfort, a reminder that even in a cavity, we are still in a medium with a direction and a drift. He lets the cavity be a place rather than a premise. Starlight crosses it and reddens hardly at all. Dust maps made from millions of stellar colours and distances show a shell around us like a patient rind, irregular and porous, opening upward where gas may vent towards the galactic halo. Young clusters sit on that rind as bright embroidery associations in Scorpius Centaurus, for example, hung like small lanterns along creases where compression helped clouds collapse. The cavity's interior is not empty but simply thin. Temperatures in the hot phase run to hundreds of thousands of Kelvin where soft X-rays originate, though. The measurements share their lines of sight with solar wind charge exchange that can masquerade as true interior glow. The air is delicate. The distances are large. The scale is planetary only in metaphor. He lets a quiet mystery remain in view without asking it to pose. How many supernovae excavate this one space? When did the first blast arrive? What fraction of the soft X-ray light is truly diffuse, and what fraction belongs to foreground solar wind interactions that imitate a sky? The numbers tighten with each new map and still leave room because the interstellar medium is structured, layered, and in motion, and because our vantage point sits inside the room we study. The cavity's wall rises around us like dusk around a lake. We walk its shore only by inferences from colour and line. The sun and its planets do not anchor the room, they pass through it. The solar system orbits the galactic centre in a wide, calm lane, and over millions of years stars drift with respect to the gas. The sun likely entered the bubble's interior in geologically recent times, then found its present seat in the local interstellar cloud, a warmer, denser ribbon within the thinness. The heliosphere, a smaller bubble of solar wind, inflates inside the bubble and answers to the local pressure, a bubble within a bubble, sunlight breathing into plasma, plasma breathing back. A dry observation settles in with the tone the project prefers. Only took a handful of massive stars living briefly and dying nearby to sculpt a cavity that holds the solar system for ages, compared to human time, and no one noticed until starlight taught them. Only required subtracting a little colour from a million stars to see that the space between them is not uniform at all. Only needed a few grains of iron found in deep ocean crusts to hint that nearby explosions left atoms on Earth, long after the light had passed, a quiet sedimentary footnote to a galactic event. He keeps the imagery elemental. Dust acts like memory here, it accumulates along the shell and deepens the outline of the room. Gas acts like breath. It thins in the centre and thickens at the edge, exhaling through chimneys where the shell is weak. Light acts like water flowing around clouds pooling in ionized regions, dimming, where grains absorb and then re-radiate as faint infrared warmth. None of these are metaphors dressed as facts. Each is a way to feel the slow gradients that physics draws in a medium too large for direct touch. He returns to consensus before moving forward. The local bubble forms in models where multiple supernovae over the past 10 to 15 million years sweep gas outward to build a cold, dusty rind. The sun's present neighbourhood, mapped with three-dimensional dust reconstructions and anchored by precise stellar distances, places young star-forming regions on this rind. Dynamics suggest that the bubble is not sealed, that it mingles with adjacent superbubbles and opens toward the halo through a structure sometimes called a chimney. Nothing here demands drama. Everything here prefers patient accumulation. Winds, shocks, cooling shells, and new stars seeded on the edges of the very void that earlier stars made. He places a second dry observation beside the first. They call it empty, yet densities in the bubble's interior still exceed any vacuum a laboratory keeps. Emptiness here is only relative thinness measured in atoms per cubic centimetre. They call it our bubble, as if it belonged to the sun, yet it was carved by other suns, and the sun merely passes through without claim. They call the wall fixed, yet it is a moving boundary, where compression, magnetic fields and turbulence reshape filaments on timescales that never bother calendars. The cavity's presence alters small things that matter locally. The heliosphere's size, the pressure at its boundary, the drape of interstellar magnetic field lines, and the flow of neutral atoms that penetrate deep into the solar system all depend on the surrounding medium's density, temperature, and field direction. Measurements of interstellar hydrogen and helium at Earth carry the signature of that flow as a subtle wind. Polarization of starlight reveals field lines curved around denser clouds on the rim. Radio maps find shells and loops that likely connect our room to its neighbours. In all of this, the Earth remains unchanged in its seasons. The continents do not shift because the air around the sun is thinner. The oceans do not notice. The relevance is not weather, it is context, a stage upon which the smaller bubble of the heliosphere writes its own outlines. He leaves the largest question unforced: what the bubble does to the rate at which stars form along its shell in our neighbourhood, and how many of the nearest young associations owe their births to compression from its growth. Observations say many. Models agree in broad strokes. The exact tallies and timings still shuffle as data improve. The idea remains simple: dying stars made space. The space's rim made new stars. the cycle's edges are what we see from within. The third dry observation finds its place and stays quiet. Only took a few million years to replace the wall's brightness with children born of pressure, and no one on Earth felt the push. Only required dust to be moved to the edge for a cavity to become visible against the galaxy's grain. Only needed the sun to be ordinary for its neighbourhood to become interesting. He keeps the tone flat and the pace slow. The Milky Way's disk does not ripple at our scale. The cavity sits like a shallow bowl set into a table made of gas and stars. It is not deep, it is not small, it is simply there. Along its boundary, molecular clouds hold their own weather cold and slow, while in the interior the warm, low-density gas keeps its looseness and carries the memory of earlier heat. Gravity does the sorting, cooling does the rest. Somewhere on the rim, ultraviolet light from newborn stars flattens the face of a cloud and writes an ionized skin over it. Somewhere else, dense cores form behind that skin and fall inward. The room is not a void, it is a context in which other rooms are constructed. He allows one gentle analogy, and then lets it go. The local bubble is like a quiet clearing in a forest where older trees have fallen, and the sunlight reaches the floor. Along the edge, saplings rise. The clearing itself is only space. The edge is where growth notices. He ends the section by setting the traveller the earth, the sun, the night sky itself within this soft geography. The solar system moves in a thin river of gas inside a wider, thinner sea. Starlight crosses a long reach of clean air before it reddens. Dust along a far wall listens to gravity and to pressure, and sometimes answers by making a star. The facts are enough: a large, low-density cavity, a shell traced by dust and young clusters, a history written by dying suns. A future in which the sun will eventually drift through another door. The mystery is the right size, how many explosions, how precisely the shell grows, how much of the solar X-ray glow belongs to the room itself. The ironies sit where he placed them and do not need to move. The room remains. The planets turn. The listener rests inside a galaxy that makes spaces as naturally as it makes stars. And in one of those spaces the night feels slightly wider than it would otherwise feel, which is another way of saying that the Milky Way breathes. He walks the room with care, measuring not with steps but with starlight. The accepted fact holds the centre without effort. The cavity around the sun is large, irregular, and low in neutral hydrogen, an egg-shaped hollow, whose longest reach spans hundreds of light years, and whose shortest spans less, with contours that refuse perfect symmetry. It is not a circle drawn on the sky. It is a sculpture laid by pressure cooling magnetic fields and time. The walls are not walls, only gradients where dust and gas thicken from the thinnest interior into a rind that telescopes can trace by how they dim and redden distant stars. He sets the picture steadily. Stars behind the cavity shine with relatively little reddening until their lines of sight cut the shell. Then colour and dimming rise as if the room's edge had finally stood up. Three-dimensional maps built from millions of stellar distances and colours assemble these rises into a topography. Lobes that protrude, bays that scoop inward, saddles that lower into couple corridors, and a broad opening that leans toward the galactic north, where the cavity likely vents into the halo like a soft chimney. The sun sits neither at the exact centre, nor near any single wall, but in a calm pocket where the interior's thinness holds for tens of light years around. A lesser-known detail belongs to the texture of that shell dust. There does not simply coat a smooth surface. It gathers in filaments and sheets that crisscross like a woven cloth, with denser knots that host cold molecular gas and thinner strands that carry polarized starlight as a signature of magnetic fields draped along their length. Polarization angles change along the edge the way grain patterns change in wood. And from those changes, astronomers read the direction in which the field lies, curved around the room, like lines on a globe with continents made of cloud. He lets geometry remain physical rather than decorative. The cavity's interior density in neutral hydrogen sits well below the typical values of the warm neutral medium. Its temperatures, where the hot phase persists, are high enough to emit soft X-rays, though foreground charge exchange in the heliosphere adds a veil that must be subtracted with patience. The shell's coldest parts harbour molecules that need shelter from ultraviolet light carbon, monoxide that marks where shielding is strong, water frozen to grains in places where temperatures stay low enough. Young stars on the shell cluster where curvature and pressure united to help clouds collapse arcs and knots that serve as lanterns pinned to the rind. The shape's irregularity is not an aesthetic, it is a ledger of past events. Multiple supernovae exploding at different places and times, winds favouring some directions more than others, neighbouring, cavities pushing and merging to carve saddles and corridors. The mystery he leaves within reach does not pretend to be larger than its evidence. How many blasts built this one room? How their timing overlapped? How much of the present outline belongs to outside pressure from adjacent cavities rather than to interior forcing? How open the chimney truly is to the halo? These remain measured in ranges, not in single answers, because maps improve in steps and the local medium keeps moving. Dust reconstructions add new stars, revise distances, sharpen edges, and the shell updates itself by a few light years at a time without changing the fact that the sun inhabits a hollow. Dry observations take their places like small flat stones. They call it a sphere in casual speech, yet every map refutes it politely, showing lobes and leanings that only lived histories could draw. They call the wall thin because drawings must use lines, yet the shell has thickness, dozens of light years in places, so that a surface is in fact a volume with its own weather. They call the whole local as if it were small, yet even the short axis swallows hundreds of light years a distance that would hold every human story with room to spare. He keeps the eye on scale by returning to the practice of mapping. Gaia provides distances like nails hammered into a frame. Photometry supplies colours that translate into dust. Radio surveys add neutral hydrogen where optical light cannot reach. Ultraviolet absorption lines in the spectra of bright background stars measure ionization and temperature along single pencil-thin beams. Each method offers a slice. Together they render a room. The result is not a single image, but a mesh that improves where stars abound and remains tentative where sightlines are scarce. Holes in the mesh are not space, only ignorance. Still, even an incomplete mesh shows that the cavity opens broadly toward the north and presses against another old cavity toward the southwest. A contact region where shells meet and thicken, and where alignments of polarization suggest fields that both spread and stitch. A gentle analogy takes one breath and stops the cavity's shape is like a snowdrift moulded by winds from several directions over many days. No flat faces, only soaps and saddles that remember gusts now gone. The interior is not featureless. Embedded within it are small, warm, partially ionized clouds that stream with coherent motion past the sun, one of which, the local interstellar cloud, hosts the heliosphere just now. Their sizes are measured in light years or less. Their densities are higher than the typical interior gas. Their boundaries are soft. Their presence hints at a history in which the cavity was never a single temperature or phase, but a patchwork even in its thinness. The edges where such clouds meet the shell become places where field lines bend, where conduction turbulence and mixing layers create thin skins that instruments treat as arithmetic more than imagery. In the shell itself, thickness and curvature matter. Regions that bend strongly focus pressure and host denser clouds. Flatter expanses remain comparatively diffuse. Open funnels into the halo carry soft flows upward that models treat as part of the galaxy's larger fountain gas, heated by star-forming regions that rises, cools and rains back into the disk. He does not hurry. Instead, the section lingers on how geometry becomes influence. The heliosphere's size and shape answer the external pressure of the medium. In a thinner interior, the solar wind can push further before it yields. Along directions where the sun's local cloud is denser, the heliosphere shrinks a little. Along thinner directions, it swells. The asymmetry is small and real, written in the times it takes spacecraft to meet the heliopause and in the flux of neutral atoms that flow inward. Even these local numbers depend on where the room's interior bends, where its filaments lie, and where the shell's nearest face sits on a given bearing. The cavity reaches into the sky we see in another way that remains quiet and steady. Through its thinness, the Milky Way's stars redden less until the shell intervenes, so constellations near clear sightlines appear a little cleaner than they would in a thicker fog. Toward the shell, nebulosity blooms in arcs and knots, some luminous, where young stars ionize their skins, some dark where dust blocks starlight. The alternating patches, clear then mottled, sparse then rich, are not mood swings, they are geometry made visible. He sets 3 more soft ironies where they can be noticed without being chased. Only took subtracting colours from millions of stars to draw a room no one could photograph in a single frame. Only required atoms per cubic centimetre to decide the sizes of structures hundreds of light years across. Only needed dying suns to clear space so that new suns could anchor the wall that marks the clearing. He returns once to numbers to keep the prose anchored. Typical interior densities of neutral hydrogen hover well below 1 atom per cubic centimetre. Typical pressures approximate those of the surrounding medium when magnetic fields and cosmic rays are counted. Temperatures shift by phase with hot plasma in the centre where it exists and warm, partially ionized gas in the embedded clouds. Shell columns of dust and gas rise by orders of magnitude compared to the interior along the shortest lines of sight to the wall. Along the long axis of the cavity, the interior path remains thin for hundreds of light years before any wall is met. These are ranges, not certainties, yet they tell the shape: fat in one direction, narrow in another, open in a third, shared in a fourth. The room connects as much as it contains. Towards certain longitudes, the shell abuts other cavities loop Y and friends, so that corridors exist where shells have merged or been pierced. In those corridors, gas finds pathways, fields, cross boundaries, and star-forming histories in separate regions may share drivers. The local bubble is not a sealed jar, it is a junction in a network. He lets the scene end by returning to how a geometry becomes a feeling without leaving science. The cavity's irregular egg holds the sun today. Its shell is stitched with filaments that collect dust gas and new stars. Its openings lead upward and sideways into larger flows. The fact remains, as it began, a low-density asymmetrical room surrounds the solar system. The lesser detail keeps its place. Polarization along the wall maps fields like grain in wood, revealing a geometry unseen by brightness alone. The mystery keeps its scale, the exact count and choreography of the blasts that carved it, the degree of openness toward the halo, the share of the soft X-ray glow that truly belongs to its interior. The ironies stay where they rest, small markers on a very large floor. The room does not claim the sun, it only hosts it. The planets do not feel the wall, they only circle their lamp. The listener does not need to name each lobe. It is enough to know that the galaxy's air is sculpted, and that for a time the solar system lives where that sculpture is hollow. He listens for warmth that does not weigh, because some of the light that outlines the room is made by gas too thin to touch. The accepted fact sits quiet at the centre. Soft X-rays produced by tenuous million-degree plasma appear along our sight lines through the cavity, and give evidence that parts of its interior or margins have been heated by ancient supernovae. Yet a share of that same soft glow is made much closer to home by the solar wind exchanging charge with neutral atoms, a foreground that can mimic a distant sky. The picture does not sharpen by force, it sharpens by patience. Thin plasma in the local bubble, if present along a line of sight, emits X-rays when electrons reunite with ions, and when ions step down through energy levels, but the emission measure is small because the density is small. The photons accumulate by area and time the way dew accumulates by night, quietly needing a wide steady surface and no sudden gestures. He lets a lesser-known detail pass near the beginning like a footnote that never raises its voice. The modern recognition of solar wind charge exchange X-rays blooms when a comet brightens in the 1990s, and its neutral coma, flooded by ions from the sun, lights up in soft X-rays no one had expected. The mechanism proves general, and Earth's own exosphere and heliosphere turn out to be similar screens upon which the sun's wind writes short-lived X-ray films. Foreground becomes a verb rather than a place. He remains with the sky, surveys that map's soft X-rays in broad bands, long integrations that tile the whole dome, see patches and arcs, cavities and brightness that seem to fit a picture in which hot gas occupies volumes between shells, and the local bubble's interior is one such volume. Yet those same surveys also see the sun's changing windright transient changes over hours to days, superimposed upon the longer structures. The task becomes subtraction with humility. Measure the wind measure, the exosphere measure, scattering and charge exchange, and then ask, what remains when the near vanishes? What remains is not just the net zero. It is a background with structure, a slow field that matches where shells and cavities are otherwise traced by dust and where maps of neutral hydrogen thin. The mystery keeps its scale and its calm. What fraction of the soft X-ray background toward a given direction is truly local hot gas within the cavity, and what fraction is solar wind charge exchange unfolding in the heliosphere and geocorona along the same sightline? The answer is not a single number. It is a range that slides with solar conditions, with season, and with line of sight. Dry observations take their places with the tone the project holds. They call it hot as if heat implied pressure, yet the pressure in such plasma can be comparable to that in much cooler gas because density is small. Hot here is the temperature, not weight. They call the glow diffuse as if it were featureless, yet maps show gradients and arcs that remember walls, chimneys and seams. They call the foreground a contaminant, yet the sun's wind is part of the very environment that shapes the heliosphere inside the cavity. Subtracting it is necessary for mapping, but understanding it is part of the same story. He keeps the imagery elemental. The hot phase where it exists is like a pale fire that has already finished burning. What lingers is light from ions settling down after shocks have long cooled to memory. The densities are measured in fractions of atoms per cubic centimetre, so the heat cannot push on a hand. It can only write quiet photons. The foreground is like bright breath on a window. The night did not intend. It appears patterns, the view, and fades with the sun's own weather. Neither image becomes a metaphor that argues. Each remains a handhold for scale. Instruments carry the discussion forward without ever speaking in voices. Detectors sensitive to different energy bands separate the softest X-rays, hundreds of electron volts, from harder photons that belong to more distant or more violent regions. Time series say what changes with the solar wind in a day. Sky maps say what changes only in seasons, or not at all. Directions far from Earth's magnetospheric cusps are quieter. Directions that pass through dense geocoronal neutrals are louder when the wind is active. By weaving time and direction, analysts build filters that do not remove the foreground so much as weigh it. When the pattern survives bright around the edges of cavities, fainter through thick dust, a quilt of glow and quiet that respects the same geography the dust maps draw. He lets a second quieter detail have its moment in some seasons as Earth moves around the Sun, the line of sight through the heliosphere's neutral helium cone. The focused downstream flow of interstellar helium strengthens the foreground charge exchange in a predictable way, adding a calendar to the subtraction. Without that calendar, some of the sky's faintest structures would blur. The cavity's heat is not evenly distributed. Where the shell is thick with cold molecular gas heat is locked out and the soft glow dims. Where the wall is fractured or vented into the halo, hot gas may leak and the glow strengthen. Where adjacent bubbles press together, the contact region may host gas that is hotter still or cooler, where mixing layers and radiative cooling prevail. Each of these cases exists in the literature not as a stage set, but as sightlines with particular qualities names not needed here, because the script prefers the shape of the lesson to the initials of regions. The broad claim stays modest. Some of the local bubble's interior is hot and thin. Some is warm and partially ionized. Embedded small clouds drift within it. The sky's soft X-ray brightness is a compound of local plasma and the cavity foreground solar wind charge exchange, and distant contributions that maps and models untangle by degrees. He pauses long enough to place 3 more ironies like pebbles that bare feet can pass without pain. Only took atoms so hot they never touched to write light bright enough to be mapped. Only required subtracting the changing breath of the sun to reveal the slow exhale of earlier forgotten heat. Only needed million-degree gas to be invisible in every sense, but one no sound, no push. Only quiet photons to understand a room otherwise drawn by dust. He returns to texture. The local bubble's interior may host islands of warmer gas filaments, where cooling has begun, and interfaces where hot meets warm, and creates a skin of intermediate ions that curve around clouds like faint auroras no eye can see. In those skins, charge exchange can also occur between hot ions and neutral atoms that stray from clouds, making Bertigny yet another contributor to soft light that models must carry. In the other direction, the same skins can conduct heat into clouds, thicken them, and then blow them apart as evaporation. Or they can under some pressures and field condense gas and add to clouds. The physics is not a tug of war. It is an algebra of flows, and the signs depend on densities, temperatures, and magnetic field geometry. He lets the algebra remain unspelled because the script's pace prefers the sense over the symbol. The view from Earth shares the same quiet duality. On some nights, the soft X-ray background looks like a stable quilt. On others, solar events drive brief brightening that remind observers that they stand inside a wind. Instruments in orbit do not leave the foreground behind, they measure it more cleanly. The separation is not accomplished by altitude, but by a counting track, the wind track, the magnetosphere track. Earth's exosphere then set their signatures aside and ask what pattern refuses to follow them. The pattern that remains is the room. A gentle analogy arrives late and then leaves the local bubble's soft glow, is like the afterheat of a kiln, long cooled, felt not by skin, but by an instrument that can sense what eyes cannot. The foreground is like a draught that comes and goes when a door somewhere else in the house is opened. Without both, the air would seem still, and it is not. He does not let the mystery swell. The open question how much hot gas truly fills the cavity, how thick its layers are near the wall, how continuous its presence is along different directions, shrinks with every new map and never quite vanishes because the wind keeps writing over the page. This is not failure. It is a property of living inside what one measures. The cavity remains its geometry independently traced by dust and young stars, even if every X-ray photon were claimed by the foreground. But not every photon is, and the balance that remains, makes the picture whole. He ends where the heat returns to being light. The cavity is not empty, it is thin. Parts of it are hot in the language of temperature and light, not in the language of pressure and weight. The sun's wind writes foreground into that view and must be listened to so that the room's quieter voice can be heard. The fact is, sufficient soft X-rays trace plasma that matches the cavity's outline and a foreground that breathes with the sun. The lesser detail keeps its seat a comet once taught the sky to glow. By exchange and the lessons stayed. The mystery remains properly sized what fraction belongs to the room on any given day, and how the distribution of that hot gas threads between clouds and through chimneys. The ironies sit where he placed them untroubled by scale. The room continues to hold the sun. The planets continue to turn inside a warmth made of photons, not of touch. The listener continues to rest inside a galaxy where even heat can be almost nothing and still be seen. He follows the line where thinness ends because along the cavity's rind gas is pressed into patience that finally gives way. The accepted fact holds the centre with ease: star formation. In our neighbourhood, clusters on the local bubble's shell, where expanding fronts from ancient supernovae and wind swept gas outward thickened it into filaments and sheets, and helped cold clouds cross the quiet threshold from drifting to collapsing. The wall is not a hard surface, it is a wide belt of denser air in a galactic sense, dust-laced, magnetized and folded where pressure and curvature gather material long enough for gravity to become the most persuasive voice in the room. Names could be listed and do not need to be arcs toward Ophiuchus and lupus knots toward Chameleon and Corona Australis longer chains toward Taurus and Perseus young stars, and their natal clouds stitched around the cavity like lanterns pinned to a woven rim. He lets a lesser-known detail pass in low light by combining precise stellar distances with three-dimensional dust reconstructions. Astronomers trace the shell as a curved expanding surface and find age gradients in young associations that point away from the cavity's interior, as if successive waves of compression moved outward and left newborn clusters strung along their paths. Not every cluster fits a single wave. Many fit the idea that pressure arrived, lingered, and rearranged the odds. Along the wall, physics slows and divides into patient acts. Diffuse atomic gas once warm cools where compression and shielding permit. Layers thicken and the column density climbs. Carbon monoxide appears when dust and density hide the interior from ultraviolet light. Temperatures fall to tens of Kelvin, and in some filaments turbulence fades enough or magnetized support weakens enough that pieces grow heavy under their own small gravities. Those pieces cause measured in tenths of a parsec quietly collapse into protostars, drawing in gas through disks, launching narrow jets and lighting the surrounding dust with a red the eye would not see without instruments. It is an old sequence written on a new wall. The mystery does not pretend to be large, it prefers to be honest. How much of the nearby star formation is truly triggered by the bubble's growth compression that makes the difference between almost and yes, and how much would have occurred in these clouds even without a room expanding underneath them, remains a question, answered in fractions and tendencies rather than in verdicts. Some regions show timing and geometry that favour a causal push. Others carry the signature of long-lived filaments that would likely have collapsed on their own. The wall hosts both kinds of stories and keeps their difference quiet. He keeps the imagery elemental so the scale can be held. Dust is the memory along the rim collecting reddening background starlight, hiding cold interiors and then re-radiating in soft infrared the heat that stars and space put down. Gas is breath thickening into weather, once a whisper in the hot, thin interior, now a slow wind organising into lanes under pressure. Light is a patient chisel, ultraviolet from freshly born stars, Sands cavities in their natal clouds while far infrared, spills from grains like warmth from banked embers tracing where matter has found shelter. Magnetic fields too become geometry at the rim. Polarization angles align with filaments sometimes running along them, sometimes crossing, gently guiding. How gas feeds cores and how turbulence decays. On some faces, the field threads the wall and slows collapse. On others, the field bends around it and a component of gravity slides along, collecting material like snow driven by a steady wind. Now and then the field's lines break and reconnect. Now and then a shock thickens a sheet into a ridge. Now and then a ridge beads into cores like dew along a blade. He leaves equations in their books and keeps the shapes in view. Dry observations take their places the way stakes mark a slow boundary. They call it a wall as if static, yet the rim drifts outward by a few kilometers per second on million-year timescales, a pace measured only by calendars the sky keeps. They call clouds dark as if void, yet darkness here is fullness, coal-dense, protective and alive with chemistry that builds simple ices on grains while the outside remains thin. They call star formation violent, yet cores fall inward at speeds that would not outrun a bicycle. Only in light do the outflows look sharp. The arithmetic of triggering carries no flame, it carries thresholds. Push the density above what thermal pressure and magnetic tension can support and collapse begins. Alter the turbulence spectrum and its decay rate and filaments bear more weight without breaking. Squeeze a sheet and it folds where it is weakest. The local bubble's shell supplies gentle repeated pushes rather than single decisive blows. Supernova remnants that helped carve the cavity long ago deposited energy that swept matter into the rim. After those events dimmed, the pressure difference persisted, and the wall lived on as a place where gas cools and collects. The sun's drift relative to the wall changes which sectors we see most plainly and which we see through chimneys, but the wall's work continues as if the observer were irrelevant. A quieter detail turns in the light newborn clusters along the rim, show stars of ages, clustered around only a few million years with spread that maps internal cloud histories rather than a single external trigger. Their disks glow in infrared. Their jets trace magnetic fields, and the feedback begins to sculpt small cavities within the larger rim, bubbles within the bubble's wall, each writing its own tiny shell. The rim's edge becomes an ecosystem of edges. He allows one gentle analogy and lets it rest. The local bubble is like a clearing whose perimeter grows seedlings. Now and again a sapling becomes tall enough to cast its own small shade and windbreak. In those lee pockets new seedlings stand. The clearing itself is not the gardener, it is the condition that makes gardening easier where edges run. He returns to facts that are sufficient without adornment. Observations place young star-forming complexes on the shell at distances and longitudes that follow the cavity's curve. Gas kinematics trace expansion on million-year scales. Maps of dust density and polarization confirm that the rim is not a line, but a layered facade. Between the rim and the interior, small, warm clouds drift, and some of these passing through the remnant pressure field may be squeezed enough to tip into forming stars in their own time. Even the component of the wall that opens toward the halo participates where the chimney leans, upflows, carry material that can cool and rain back onto the disk, elsewhere seeding the interstellar medium with matter that once lay near our sun. The neighbouring superbubbles matter too. Where the local bubble presses against another, a thicker seam forms. Along that seam, geometry focuses pressure and star formation becomes more likely than along a flat expanse. The rim is stitched to other rims. The nursery is not a room, but a boulevard with many addresses. Ironies settle where they can be stepped over without breaking stride. Only took exploding suns, brief lives ending, in outward breath to lay down the quiet grammars where slow, cold clouds could finally make new suns. Only required densities measured in a handful of atoms per cubic centimetre to decide over millions of years where stars gather by the thousands. Only needed dust grains smaller than pollen to hide light so that molecules could knit in darkness while the galaxy moved on. The chemistry of darkness makes its own patient case. On grain surfaces, hydrogen meets oxygen to form water ice. Carbon and oxygen assemble carbon monoxide that later traces the densest rooms. Nitrogen and carbon find CN and HCN in pockets where shielding is strong. None of these molecules makes the star. They are the weather in which gravity does its work, leaving signatures that spectra translate. When seeds become stars, their radiation cuts cavities, their winds and jets drill pillars, and their ionization fronts ripple across nearby walls. Feedback can compress and erode the double action by which the rim persists as nursery and quarry both. Some young clusters near the rim host stars massive enough to begin this cycle again. Others hold only smaller suns whose light and wind carve gently and then wane, leaving the wall roughened but still standing. The wall's thickness keeps these stories from merging too easily. A few dozen light years absorb much without breaking. He keeps a second mystery in view, small and correct, how far the bubble's expansion and pressure have marched the timing of births along the wall, and how much the magnetic geometry has funneled material into favoured filaments remains under revision as maps improve. Age, datings of clusters, kinematic reconstructions of shells and three-dimensional dust atlases add lines to the ledger each year. The broad shape holds the details learned to sit. The sun's role in all this is neutral and observational. It moves inside the clearing while seedlings rise on the edge. Its heliosphere feels the local clouds, not the birth cries on the rim. Earth's night receives starlight from those new populations with less reddening from interior thinness and more contrast when a wall cuts the line of sight. Human eyes translate those differences into constellations thick here and sparse there, never guessing that a cavity set their background. A last trio of dry observations sits down near the close. They call the rim an edge, yet it is a belt, and within that belt are smaller belts where different pressures and fields prevail. They call new stars newborns, yet most are already a few million years old the moment we notice them. Youth in astronomy is simply the slowest adulthood. They call the wall a product of death and treat that as paradox, yet in the interstellar medium endings and beginnings, trade work as calmly as seasons. He lets the section rest where the wall becomes feeling without ceasing to be fact. Along the bubble's rind, cold gas lies in shadows that dust makes. Compression from old events and gentle continuing pressure support filaments until they cannot be supported. Cores collapse the way stones finally fall from a hand opened slowly. Young stars switch on and send their own fields and winds into the same wall that gave them shelter. The facts remain precisely sized star formation clusters on the shell. Age gradients and geometry point away from the cavity's interior. The role of triggering is significant but not exclusive. The lesser map-based detail keeps its seat three-dimensional dust and distances let the wall be drawn and timed in relief. The mysteries hold their shapes without ambition, fractions, sequences and field-guided flows. The ironies keep their quiet. The room stands, the edge makes stars, and the galaxy continues to breathe. He listens for endings that act like tools because the rim that holds the room is carved by dying suns. The accepted fact rests in the middle with the steadiness of a slow-tide multiple supernova. From nearby stellar associations expand through the interstellar medium over the last 10 to 15 million years. Their shocks sweeping gas outward, piling dust into a rind and leaving a low-density cavity where the sun now drifts. The story prefers continuity to spectacle. Massive stars in clusters live briefly millions of years, not billions, and thus their winds pre-shape the air around them before they collapse and explode. Each blast inflates a bubble, overlapping bubbles merge, pressure smooths jagged edges into broad shells, cooling turns hot interiors into warm corridors, and the combined structure settles into a super bubble, whose wall becomes a map of where momentum and time have agreed. He lets a lesser-known detail pass under soft light. A single supernova's life in the medium travels phases, with quiet names, free expansion, then the Sadov-Taylor stage, where energy spreads in a self-similar pulse, then the radiative snowplow, where cooling turns the shock into a momentum-conserving front, and in a tenuous environment like this cavity's interior, those phases run long so that a sequence of explosions can maintain pressure and keep the wall from sagging. One blast does not make the room, a cadence does. The likely drummers live nearby in the language of the Galaxy OB subgroups of Scorpius Centaurus and their kin, moving associations whose bright children are now seen along the shell, and whose missing elders, already ashes, once breathed the pressures that cleared the centre. He keeps their names in the background and lets their work remain foreground. The shock physics does not argue. Hot gas newly shocked expands. Density behind the shock first rises and then falls as the interior cools. The pressure pushes on any neutral hydrogen in its way, compressing it into a sheet. Magnetic fields bent and strengthened in that sheet guide how the gas later slides and how turbulence decays. Where the sheet meets pre-existing clouds, it thickens them. Where it meets voids, it accelerates without brightening. Shells intersect. At their seams, density doubles and structure stiffens. The result is not a circle. It is an irregular egg moulded by where the supernovae happened and by what they met. The mystery remains sensibly sized. How many explosions built this one room? How they were spaced in time, whether a handful of unusually energetic events dominated or whether many modest ones shared the work. How much of the interior's present heat comes from those early epochs versus later mixing and conduction. These stay in ranges rather than in declarations. Backward integrations of moving groups, radio shells that overlap three-dimensional dust reconstructions, and traces of short-lived isotopes on Earth all point toward a choir of endings rather than a solo, but the score's exact measures are blurred by time. Dry observations sit down with the mildness the project keeps. They call it a chain of events, yet each supernova is itself the end of a chain accretion, fusion wind, and then the briefest correction in pressure, and the room is the sum of many chains' endings. They call the wall a record of explosion, yet most of its present form is cooling, compression and magnetic patience, not speed. They call the cavity empty, yet it holds the residual heat of absent stars as thin light, which is just another way of saying it is still filled with what is gone. He keeps the imagery elemental, so the scale does not slip. Dust along the wall is compacted weathered ash grains grown in older winds and outflows, herded into filaments by the moving pressure. Gas in the interior is breath that has been exhaled and left to spread thin, a warmth that cannot be felt and still keeps its ledger. Light is the chalk that records it all, soft X-rays from the afterheat, faint radio from hydrogen that holds its spin, polarized starlight from field lines stretched along the wall. The choreography repeats with small differences as each blast arrives. A star collapses, a wave runs, the wave slows and cools, the cooled shell keeps moving under its own momentum. New stars on that shell will later add their winds and smaller bubbles, and where two shells press the ridge between them grows denser, either wall alone. Somewhere the local bubble touches a neighbour, and the seam becomes a shared street. Elsewhere it leans open toward the halo, and the flow escapes in a local chimney. He lets one gentle analogy draw a short arc and then be still. The room is like a clearing, made not by one tree falling, but by a grove coming down in a storm across several seasons. The floor is open because many trunks are missing, and at the edge saplings lift their leaves into the new light. The sun enters the clearing late, and only walks across it. A quieter detail sets the dying star's work against Earth's archives. In marine crust and Antarctic snow grains carry traces of ions and a radionuclide with a half-life measured in a couple of million years, a signature of nearby supernovae that leaves faint peaks at times separated by millions of years. The isotope is not a clock for the wall yet. It speaks to the right scale events within a few hundred light years, recurring on times that match moving groups' lifespans and consistent with the idea that endings fed the clearing. Filtered by the heliosphere, carried as dust settled as atoms, those traces are small enough to be violent and large enough to be heard. He does not let their existence pretend to name a star. They name a practice. The dynamics of the rim breathe on million-year lungs. Momentum from many blasts is added like deposits in a slow account. Radiative losses draw down the balance. The shell expands into density gradients faster, where the medium is thin and slower where it is thick. Field geometry decides where the shell can slip and where it has to fold. Along its face, the mass per area rises until gravity notices, and then sections for's quiet truth. The density shelters molecules and seed stars. The superbubble's pressure, no longer violent, becomes a floor beneath which the interior hardly falls, and a ceiling above which the wall hardly rises. The room living on in a galaxy that does not mind if rooms come and go, is bound not by doors but by habit. Another trio of ironies lays down like flat stones beside a path. Only took a few lives measured in millions of years to draw a shape that holds the sun for tens of millions more. Only required matter thinner than any earthly vacuum to remember force enough to rearrange dust gas and the timing of nearby births. Only needed the end of fusion in giant hearts to make the conditions in which faint cool chemistry could begin. The physics answers quietly when asked how a series of spherical shocks yield such a crooked edge. Environments are not uniform. Density field and pre-existing structures tilt every wave. Off-center explosions push the wall more here than there. Later events invade into space already cleared by earlier ones, reaching farther and shaping new lobes. Contact with neighbors stalls one side while another keeps running. Irregularity is not a noise, it is the record of specifics. He lets a second, softer detail fold in ejecta from the explosion's metals forged in the cores mix into the shell, and later into new stars raising abundances that future spectra read as family trait. The clearing and its rim do not only change geometry, they adjust composition. The room becomes not just a place but a flavour. The heliosphere feels these legacies without knowing their names. External pressure from the cavity's thinness allows the solar wind to run farther before it yields. Direction of the interstellar magnetic field draped by the wall and its embedded clouds sets the heliosphere's asymmetry. Neutral atoms from the surrounding flow enter and write their own small focusing cone downstream of the sun. None of this is dramatic and all of it is persistent. The planets do not wobble because of the rim. Earth's climate does not tilt because of an old shock, but the boundary conditions for the sun's own bubble are set by a room built by endings, and that boundary is where probes have crossed and measured change. He lets the memory of heat return to being only light. Some sightlines through the cavity hold million-degree plasma whose pressure matches the surroundings when fields and cosmic rays are counted, a balance that claims no urgency. Other lines find warmer gas and small clouds islands in a sparse sea. In every case, the wall's continuation depends on the ledger of momentum left by long-ago blasts, and on the slow leak of energy into radiation. If another supernova in a nearby subgroup were to add its breath, in some millions of years the wall would receive new impetus, and the cavity might lean further in one direction, open wider in another, press a seam harder somewhere else. He keeps the mystery from swelling. The identities of the particular giants that ended, and the exact order of their endings, are beyond recovery. The number of events carries uncertainties because shells overlap and orphan their edges. The share of present soft X-rays that truly belong to the interior versus the heliospheric foreground is a moving fraction that models keep improving. None of these ambiguities move the fact-dying sun sculpted the room. None of them erase the quieter corollary. The rim their blasts built now grows stars of its own. He rests the section by letting the sequence breathe once more in the fewest necessary words. Winds prepare, supernovae drive, shocks sweep, walls cool, fields bend, molecules shelter, stars begin. The sun passes through indifferent and included. The clearing extends by slow inches, then holds. The facts stay where he placed the many explosions, not one. A timescale of 10 to 15 million years. A wall that continues to collect and a centre that continues to thin. The lesser snowplow detail keeps its chair a reminder that after drama comes the patient phase that actually builds the rind. The mystery keeps to its right size, counts timings and shares. The ironies stay small and true. The room breathes out. The galaxy goes on. He lets the sun take its seat inside the room, because a traveller still needs a chair even in a clearing. The accepted fact rests at the centre without asking. Over the past few to several million years, the solar system drifts into the local bubble, and now moves within a warmer, slightly denser filament embedded in its thin interior. The local interstellar cloud, while the sun's own wind inflates a smaller bubble. The heliosphere that rides this flow like a lantern's halo carried through calm air. The motion is quiet and precise. Against nearby stars, the sun follows its broad galactic path, but relative to the cloud around it, a gentle headwind arrives from a particular direction, and neutral helium atoms from that wind slip past the heliosphere's magnetic skirt, skimming inward on straight lines until the sun's gravity focuses them into a faint downstream cone. Instruments taste that cone each year as Earth passes through it, sampling a fragrance of the galaxy, in the form of counts and energies that only make sense when the room is thin and the flow is steady. A lesser-known detail stands politely beside this tasting. The same inflow reveals a warm breeze, a secondary helium population likely bent and heated at the heliosphere's boundary before curling in a quiet signature that the edge is not a line but a region with its own weather. He measures the seating arrangement with boundaries and lets numbers stay unraised. The solar wind leaves the sun in supersonic strands and slows at the termination shock. Beyond in the heliosheath it drifts until it meets the heliopause, a contact between solar and interstellar plasmas. Farther still, interstellar neutral hydrogen piles into a faint hydrogen wall, where charge exchange and compression thicken it. Probes have felt these thresholds in passing sudden changes in charged particles and fields that say boundary rather than wall, yet the physics remains small in pressure compared to the architecture of the local bubble itself. The heliosphere is a bubble inside a bubble, its size and asymmetry set by the surrounding cloud's density, temperature and magnetic field direction, and so long as the sun resides in this warm wisp inside the clearing. The lantern's halo keeps roughly the same shape longer, where the field and flow allow shorter where they resist. A mystery remains visible and sized for the scene. The exact timing of when the sun entered this cloud, how thick the cloud is along our way, and when the sun will slip into the next filament are all known to within orders of tens of thousands to hundreds of thousands of years rather than dates, because distances between cloudlets are measured in light years, and our drift in handfuls of kilometers per second, maps improve the course, stays smooth, and the calendar refuses to sharpen. He keeps the imagery elemental. Dust from the interstellar flow is a sparse snow that at certain sizes penetrates the heliosphere and continues inward grains, so few they count as single stories. The solar wind, a warm expanding breath, meets that snow and charges. Some grains turn some atoms into pickup ions that ride magnetic spirals outward and sends a fraction back as energetic neutral atoms that instruments translate into faint global pictures of our own boundary. The galaxy becomes knowable in these delicate byproducts. A ribbon of enhanced emission hangs where the local interstellar magnetic field stands nearly perpendicular to the line of sight, a tracer that says direction without insisting on magnitude. Neutral atoms in yearly rhythms repeat the inflow's bearing like a soft compass set into the dark. He lays 3 dry observations where they settle of their own weight. They call the sun's environment empty, yet even here atoms arrive regularly enough to draw cones and walls and to seed a few microparticles onto detectors. Emptiness is only a thin presence counted honestly. They call the heliosphere a shield, as if fortress, yet it breathes with the solar cycle broad in quiet years, tighter in active years, and its defense is modulation and delay, not refusal. Protection here is timing, not storm zone. They call the local interstellar cloud a cloud, as if fog bank, yet it is a barely thicker thread woven through thinner air, warmer than cold clouds and cooler than hot plasma. Its edges soft, and its interior almost featureless to senses that grew in weather. The sun's seat shifts by small inches in galactic terms. Star catalogues show that today the sun sits near the local bubble's center line. Though center is a courtesy granted to shapes that refuse a point, kinematics suggest the bubble's shell grew outward as stellar associations aged, so that the sun's path toward its middle is less a choice than a coincidence of motions, stars, drifting walls, expanding cloudlets streaming with their own coherence inside a larger coherence. By this quiet arrangement, the solar system has spent recent geologic time in lower density surroundings than it would find inside a classical cold cloud, and the heliosphere has likely extended farther than it would in denser air. Cosmic rays, the charged messengers from supernovae and other accelerators, feel this seating through changes in modulation as the heliosphere swells or contracts with solar cycles and with external pressure. The spectrum that reaches Earth tilts and lifts by modest amounts, recorded by monitors that never sleep. The clearing's air becomes part of the background for a planet that dresses itself each day and night without knowing why the dressing room is the size it is. He allows one gentle analogy that then leaves the stage. The sun is a ship crossing a shallow clear bay after sailing in deeper water. Its wake is the heliosphere. Its keel sets the direction of the focused helium, and the bay itself is only a change in depth, drawn by ancient tides of supernova that have already run out of words. A quieter detail steps in and rests. The very neutral helium that maps the flow travels unimpeded where neutral hydrogen cannot, because solar ultraviolet light ionizes hydrogen more readily. Helium stays honest, and so the helium cone becomes a cleaner yardstick for the local wind, a population that passes quietly through photon wards that stop others. The sun's seat sits within a network. Adjacent cloudlets move with related velocities as if fragments of a once larger sheet. Beyond them, the bubble's wall holds star-forming complexes like lanterns hung at a distance. In certain longitudes, the rim opens toward the halo, and the clearing becomes a chimney that connects disk to sky. The solar system notices these only as shifting external pressures and fields. Its own days are not moved by them, yet its boundary is. When interplanetary shocks thrown outward by solar eruptions plough through the heliosphere and reach the heliopore's faint radio lines at a few kilohertz, announce the meeting sounds of a kind the ear cannot hear, and in time those sounds turn off when the boundary changes. Inside Out, Outside in the lantern's halo hears both. He places 3 more soft ironies where they belong, only took a handful of helium atoms per cubic centimetre, less, in truth, to give the solar system a measurable wind, and a downstream cone the size of a planet's orbit. Only required a field too faint for human instruments in air to mould a vast invisible boundary into a shape that probes could cross and clocks could mark. Only needed a thread of warm gas within a clearing to set the furniture for our smaller bubble, and to leave the continents unmoved, the seasons untroubled, the oceans unaware. The uncertainties do not try to be larger than they are. The precise thickness of the local interstellar cloud along our path, the exact angle the interstellar magnetic field makes with the flow, the detailed layering of plasma and neutrals in the outer heliosheath, each remains under refinement as missions map energetic neutral atoms, as polarization surveys trace fields as absorption lines against bright, nearby stars add points to a sparse grid. Entry and exit dates for the present cloud are therefore sketches thousands to tens of thousands of years already spent inside, thousands to tens of thousands more perhaps remaining. Then another filament similar or slightly different with boundary conditions that will resize the heliosphere by a few dozen astronomical units and change the timing of cosmic ray modulation by amounts that interest instruments and leave weather alone. The seating chart is not a plot, it is a succession. He leaves the sun where the clearing makes sense without ornament. The local bubble's thin interior allows starlight to reach us with little reddening, until the rim intervenes. The sun's lantern halo glows within this thinness and writes its edges by interactions with the room's sparse air. Helium honest as a weight gathers downstream. Dust rarer than the mind expects still paints trails on detectors and arcs on sky maps. Fields too soft to lift a leaf bend cones and bow shocks into quieter symmetries. If the sun entered the bubble a few million years ago, as maps and moving groups imply, then the room's geometry changed our background since a time when hominins first used stone. If the sun exits the present cloud in the future measured by ice ages, rather than by continents, then another thread will take this seat and the furniture will subtly rearrange while Earth continues the same steady circuits around its lamp. He closes by letting the fact, the detail, the mystery and the ironies sit where he placed them and not insist. The fact that the solar system lives inside a warm thread of gas that drifts within a larger low-density cavity, and the sun's wind shapes a smaller bubble that answers to both. The detail, a focused cone of interstellar helium and a secondary warm breeze, reveal the flow and the boundary's character without touching it. The mystery timing, thickness and precise field geometry remain ranges, not dates and diagrams. The irony's emptiness draws maps, shields, breathe, clouds are threads. The room holds. The chair sits in its place. The planets keep turning beneath a wind that carries almost nothing, and yet leaves measurements the way a quiet day leaves a page filled with the small, careful notes. He stays with the thread itself because a single strand inside a clearing carries more structure than emptiness suggests. The accepted fact sits plain and sufficient. The sun presently moves through the local interstellar cloud, a warm, partially ionized, low-density cloudlet, with temperatures of a few thousand to about 8,000, Kelvin and densities well below 1 particle per cubic centimetre, and this cloud is only one piece of a cluster of similar cloudlets streaming past with coherent motion inside the local bubble. The stream is quiet but organised. Nearby targets show absorption lines of neutral and singly ionized atoms, sodium, calcium, magnesium, whose small Doppler shifts a range into a patterns, pointing to a common flow direction and speed. Hydrogen is partly ionized by stray ultraviolet light. helium stays largely neutral and becomes the faithful tracer that slides into the heliosphere untouched by photoionization. Within this thread, the sun's small bubble breathes, and the boundary conditions it feels, the external pressure, the field direction, the mix of neutral atoms are set by this thin cloud and its neighbours, rather than by the bubble's wider interior. A lesser-known detail belongs to taste more than to sight interstellar dust of specific sizes, not too small to be tied by electromagnetic forces, and not too large to be entirely excluded by radiation pressure, penetrates the heliosphere as a trickle revealing the flow's direction on dust detectors and leaving a faint, steady drizzle of micron-scale grains that describe the same wind as the helium, a second granular handwriting across the same page. The thread has edges and he lets them be soft. At the cloud's boundary, the ionization fraction changes, fields bend, and temperatures tilt by small degrees. In some directions, the sun may be within a few tenths of a parsec of such an edge, in others, comfortably interior for longer. The surrounding cluster, the fluently named complex of local interstellar clouds, includes siblings with slightly different densities and velocities, some cooler, some warmer. The sun's path will in deep time, measured by tens to hundreds of thousands of years, carry it from this thread into a neighbour, perhaps the so-called G-cloud or another shard of the same sheet with a drift so moderate that the heliosphere's size will change by fractions rather than by orders, a wider lantern in thinner air, a tighter lantern in thicker. The mystery keeps to that humanly invisible schedule, whether the transition is imminent on geological calendars or distant by multiple ice ages, and whether the boundary is a smooth gradient or a textured series of folds, remains a range rather than a timetable, because maps stitch together pencil-thin sightlines between bright nearby stars, and the gaps between those pencils are still larger than the trims people prefer. The cloud's field is a compass with a flexible needle. Polarization of starlight hints at orientations. The enigmatic ribbon of enhanced energetic neutral atoms seen in global sky maps orients itself roughly perpendicular to the local interstellar magnetic field, as if pointing along shells of constant pitch angle. Radio emissions triggered when solar shocks reach the heliopore's whisper, changes in the boundary's shape as solar cycles push and relax. Together, these lines of evidence place the field at a slant to the flow, not head-on, and the heliosphere stretches accordingly into a slightly asymmetric drop, longer, downstream, a little pressed upstream, tilted just enough to matter to instruments and not at all to seasons. He lays 3 dry observations where they won't ask for comment. They call it a cloud, as if thick, yet the column density to the edge in some directions is so small that a person could count the atoms in a cube the size of a room and finish the list before the day ends, if only counting were that honest. They call it warm, as if touch yet warmth here is kinetic statistics over miles between collisions, a temperature felt by line widths and not by skin. They call the edge soon or far, as if a border crossing, yet the change for Earth is a drift in the timing of particles measured by silent counters, not a new wind in trees. He returns to the thread's internal weather, the kind too small to see and large enough to matter. Partially ionized gas means pickup ions are made when neutrals enter the heliosphere and give up electrons. Those pickup ions, borne on gyroscopes of magnetic field lines, populate shells in velocity space and then seed anomalous cosmic rays when shocks accelerate them. In the opposite direction, charge exchange between solar wind ions and incoming neutrals produces energetic neutral atoms that race back inward on straight paths, painting a global image of the boundary that only instruments can read. The heliosphere's outline thus becomes a mirror of the cloud's properties. Tighten the external pressure and the mirror shrinks. Slacken it and the mirror expands. Change the angle of the field and the mirror tilts. Instruments read these changes as if feeling a room by echo, yet the room is the cloud and the echo is a map made of particles. A quieter detail slips in neutral hydrogen from the cloud does not travel as faithfully as helium, because solar ultraviolet photons strip its electrons more efficiently. As a result, the hydrogen wind is muted and the helium wind remains the clean signal. A practical asymmetry that makes the helium focusing cone a better seasonal rhythm and the hydrogen wall at the heliopause a subtler boundary. The thread's chemistry is modest and honest. Along sightlines to bright neighbours, interstellar lines reveal column densities of trace species and ratios that imply depletions of certain elements onto dust iron and silicon, tied into grains that survive the warm medium carbon, partly in gas, partly in dust. These depletions change gently from cloud to cloud, hints that histories differ even among siblings. Some threads have seen more shocks and lost more mantles. Some have sheltered longer and kept their coatings. None of this changes what the sun fills day to day, yet it tints the dust drizzle and the exact slope of extinction in the nearest sky. At the edge, contact layers of mixed temperature may develop thin skins, where conduction turbulence and charge exchange make intermediate ions that quench or feed heat leaks between phases. He lets the equation stay unnamed. The narrative belongs to proportions, not to forms. He sets another trio of soft ironies like small markers on a calm trail. Only took atoms separated by distances large enough to hold mountains between collisions to write line widths that give temperatures with more precision than a hand could guess. Only required grains smaller than pollen to enter the heliosphere as a handful per day, and still describe the wind better than a flag would in a storm. Only needed a field too light to raise dust in a room to bend a boundary the width of the solar system by degrees instruments can agree on. The sun's course through the cluster of clouds is not a plot, but a drift along a braided current. Kinematic reconstruction suggests that the local cloudlets belong to a larger flow, moving away from certain star-forming regions, perhaps remnants of the same pressures that built the local bubble's wall. Fragments shear collide gently, and separate leaving islands of warm gas threaded by fields and nudged by residual waves. The sun crosses one such island now. Earlier it may have crossed the blue cloud a smaller neighbour. Later it may meet a slightly cooler stream. Each crossing would resize the heliosphere by a modest fraction, and adjust the modulation of cosmic rays by rhythms measured in counts, not in colours. The continents remain unaware. Auroras answer solar storms, not interstellar changes. The atmosphere's chemistry tallies greenhouse gases and volcanoes, not the passing of a cloud whose density is an atom whispered into a cube the size of a sugar lump. He allows one gentle analogy and lets it fade. The sun is like a small boat gliding through a web of silk strands laid across a wide, still pond. The strands are almost nothing to the hull and everything to the pattern the wake makes. The boat does not choose the pattern, it only reveals it. The cloud remains part of a network broader than any single room. Corridors link this cavity to Loop 1 and other superbubbles. The field lines threading the cloud also thread those corridors. Soft flows exchange plasma with the halo through chimneys that open above. In such company, a cloudlet is a syllable in a paragraph about the disk's breadth, not a sentence alone. Instruments keep reading syllables because paragraphs take time. The fact when given the last word of the section is spare and sufficient, the sun moves through a warm, partially ionized cloud embedded in the local bubble, and that cloud's density, temperature, and magnetic field direction set the heliosphere's present size and lean. The lesser detail holds its seat a sparse rain of interstellar dust and a disciplined stream of neutral helium right the flow into detectors, one granular, one atomic, both patient. The mystery remains deliberately small where the edge of this thread lies along our future track, how its field twists beyond that edge, how the cloud sequence will change the heliosphere's furniture by degrees rather than by leaps. The ironies rest where they belong. The thread drifts, the lantern breathes, the room stays thin. The planets keep turning inside the wind that almost isn't, which is another way of saying the galaxy's air is present enough to measure and absent enough to ignore. He holds the smaller bubble inside the larger, because a boundary nested within a boundary explains more gently than any edge alone. The accepted fact is plain and sufficient. The solar wind carves the heliosphere, a cavity of magnetized supersonic plasma inside the local bubble, and where that wind slows turns subsonic and finally meets the interstellar flow. A sequence of regions appears that spacecraft have crossed and instruments have mapped in particles rather than in light. Closest to the sun, the wind streams outward, hot and fast by solar standards, carrying embedded magnetic fields that spiral with rotation. Farther out, at tens of astronomical units beyond the giant planets, the wind slows at the termination shock, becomes a warmer, subsonic flow in the heliosheath, and then meets the interstellar medium at the heliopause, a contact that separates plasma of solar origin from plasma of the galaxy. Beyond that, contact-neutral hydrogen in the local interstellar cloud piles into a subtle hydrogen wall. Depending on the interstellar Mach number, there may be no true bow shock ahead of the heliosphere, but only a bow-like wave, a compression without a discontinuity, a front that announces itself in behaviour rather than in a line. He leaves names in their places and lets the structure speak. The termination shock is where pickup ions, neutrals from interstellar space ionized inside the heliosphere and swept into gyromotions become a warm reservoir that the slowing wind must carry. The heliosheath is the long subsonic corridor where that reservoir mixes and relaxes under stresses the ear cannot imagine. The heliopause is the thin skin where pressures balance and fields drape. The outer heliosheath is the interstellar side warmed and stirred by charge exchange and by magnetic geometry. Across these layers, intensities of galactic cosmic rays rise and fall. Energetic neutral atoms born by charge exchange race back inward on straight trajectories and paint an all-sky image in particles of the shape the wind has made. Magnetic field strength and orientation change across a span so small that a probe's instruments record a boundary in minutes, even though the boundary itself is measured in astronomical units. A lesser-known detail sits where it belongs. Modest and true interstellar hydrogen atoms, unlike helium, are photoionized efficiently by solar ultraviolet light, so they filter out before reaching the innermost regions, but helium remains neutral almost everywhere until it nears the sun. As a result, the focused helium cone downstream provides a clean seasonal yardstick for the interstellar flow, while the faint hydrogen wall just outside the heliopause provides a subtler stationary yardstick for the boundary's existence, two traces that together say wind without needing a weather vane. The shape of the heliosphere is not a toy diagram. It is a compromise between flow and field that instruments read in riddles and answer with patience. For decades, a comet-like tail was the default sketch, a long downstream extension blown by the solar wind into the interstellar stream, but global maps of energetic neutral atoms and models that fold in the draped interstellar magnetic field have proposed a broader, blunter structure, perhaps with two extended lobes where field tension resists a narrow tail, a croissant-like figure that is still only an inference, not a photograph. The mystery that remains is sized for this kind of evidence, whether the heliosphere carries a single long tail or bifurcated lobes, how thick the heliosheath is in different directions, how the boundary ripples under the push and pull of solar cycles, and whether small-scale reconnection opens transient windows where solar and interstellar plasmas exchange particles, each question sharpened by years of mapping and still durable enough to keep its edges soft. He lays 3 dry observations down like flat stones. They call the heliosphere a shield as if wall, Yet its defense is delay and modulation. It slows some cosmic rays, filters some neutrals, and changes with the sun's own weather. Protection here is timing, not armor. They call the boundary a surface, as if it could be wired like a fence, yet it is a region in which densities, fields and flows grade over dozens of astronomical units, while instruments name a crossing in an hour because their sensitivity steps across thresholds. They call its discovery recent, yet the wind that makes it has blown since the sun first spun, and only human instruments are late to the room. He keeps the imagery elemental so no line tightens too much. The solar wind is breath warm enough to expand, but thin enough to forget weight. The heliopause is a skin held by pressures, not by matter. The interstellar flow is a current so slow to notice that only long integrations of particles and fields can register its direction. Field lines drape around the heliosphere like strands of silk drawn across a moving object. Charge exchange stitches the two media together at their seam, trading momenta through invisible handshakes that leave neutral messengers to carry news back inward. In that inward news, a ribbon appears, a long arc of enhanced energetic neutral atoms roughly perpendicular to the local interstellar magnetic field, as if pointing not to the boundary's position, but to the field's angle itself. The ribbon's persistence across solar cycles is gentle and instructive. It does not resolve the shape by itself, but it locks the compass, reminding modelers that field geometry is the quiet sculptor and flow only its clay. He lets spacecraft cross in one sentence because the script prefers pace to catalogue. Probes sent outward decades ago feel the termination shock drift through the Helios heath and record a sudden rise in the interstellar magnetic field's steadiness and a drop in solar origin particles when they cross the heliopause. Later, a second probe in a different direction confirms that the boundary sits at different distances, asymmetrically placed by field and flow. Past the boundary, cosmic ray intensities lift toward the interstellar value. Inside, solar modulation holds their spectrum down. The numbers matter to mission teams. Here the lesson is enough. The nested boundary is real and it breathes. A gentle analogy rises and then rests. The heliosphere is like a lantern carried through a thin mist. The flame's heat makes a pool around it, the mist pushes back, and the size of that pool changes with the flame's mood and with the drafts in the room. The drafts here are the local clouds' density and temperature and the interstellar field's direction. The mood is the solar cycle's cadence of fast and slow wind eruptions and calm. With each cycle, the termination shock shifts a little. The heliopause pulses by a few astronomical units and radio whispers at kilohertz announce when solar shocks finally touch the boundary and ring it like a low bell. A quieter detail belongs to the arithmetic of pickup ions. As interstellar neutrals slip into the heliosphere and lose electrons, they are born hot in the frame of the solar wind, gyrating around field lines and quickly forming shells in velocity space. Those shells, scattered into wider distributions, become a substantial part of the Helios heath's pressure budget. When the wind slows at the termination shock, much of the shock's work is simply to heat this population. This bookkeeping matters because it explains why the shock is weaker than simple expectations, and why the Helios sheath's thickness is what it is. Most of the energy goes into particles that were not even part of the wind in the inner system. Dry observations continue their patient walk. Only took a few atoms per cubic centimetre on the outside and a few protons per cubic centimetre on the inside to build a boundary tens of billions of kilometres wide that instruments can cross and clocks can time. Only required trading a single electron in charge exchange to launch neutral messengers that draw a global map of a cavity no camera can see. Only needed the sun's own small storminess to make a breathing room whose pulse periods write themselves into distant counts of particles that no eye could notice. He keeps the Heliotales debate where it belongs, open, constrained and gentle. If a narrow tail exists, it likely extends thousands of astronomical units before mixing away. If lobes dominate, they are held by the draped interstellar field's tension and relax, downstream like braids. Both pictures accept the same facts that the termination shock is closer upstream than downstream, that the heliosheath's thickness depends on direction, that solar cycle variations ripple outwards and change intensities by modest percentages, and both yield to the next map that carries more signal and fewer assumptions. This uncertainty is not a failing. It is the difference between measuring from inside and seeing from outside, and inside is the only vantage offered. He returns briefly to the way the local bubble sets the furniture. Because the surrounding cavity is thin, the interstellar pressure the heliosphere pushes against is modest. As a result, the heliosphere finds room to extend farther than it would inside a cold, dense cloud. If the sun later passes into a slightly denser thread, the termination shock will draw inward, and the heliopause with it, and galactic cosmic rays will press a little closer. Changes that matter to monitors and leave weather indifferent. Field direction also owes a debt to the bubble's wall, the interstellar magnetic fields draped by nearby filaments, and clouds inclines across the heliosphere, lending it the mild asymmetry that probes recorded and models now expect. He lets cosmic rays have a quiet seat in the corner. At high energies they cross the heliopause freely. At lower energies they feel the modulation of the solar wind's turbulence and the moving obstacles of the solar cycle. From one cycle to another, the flux at Earth rises and falls by amounts that settle into long-running plots. Against those plots, the broader, slower change in the heliosphere's size under external pressure is a subtle skew, a background that shows only when many cycles are seen together. Such is the scale of influence a thin cloud has on a planet's particle weather. He ends by letting the nested boundaries become a mood rather than a diagram. The solar wind flows, the termination shock breathes, the heliosheath drifts, the heliopause holds, the interstellar medium slides past with patience, field lines curve, neutral atoms trade places with ions and carry messages in straight lines that instruments catch in quiet rooms. The accepted fact remains where he put it, a bubble, within a bubble sculpted by flow and field measured in particles and crossings. The lesser detail keeps its calm place helium honest to the core, and hydrogen gathering as a wall together marking wind and boundary. The mystery stays appropriately open tail or lobes fixed distances, or living margins, windows that open and close in reconnection. The three ironies lie where they were left small and clear. The room remains thin, the lantern continues to breathe, the planets keep to their circuits inside a boundary that almost no one feels, which is another way of saying that the galaxy sets the stage and the sun quietly lights it. He watches cartographers of darkness sow a room from light, because in this neighbourhood, maps are made by what stars lose as they pass through dust. The accepted fact sits calmly in the centre three-dimensional reconstructions of interstellar dust enabled by precise stellar distances and colours, now trace the local bubble shell as a curved expanding surface linking nearby star-forming complexes to that surface with ages that spread outward like quiet rings. Parallaxes turn sky into depth. Photometry turns depth into extinction. Millions of sightlines become a loom. Each star measured in distance and colour contributes a thin column of information how much dust must lie in front of it to redden its spectrum by the observed amount, and therefore where along its line of sight the first notable veil must sit. Tomographic methods take these columns, assume smoothness where stars are sparse, and texture where they are dense, and solve for the dust that best explains all of them at once. What emerges is not a photograph but a relief, a softly shaded rind around the sun with bays and saddles, a lopsided cavity whose floor is thin enough that light passes clean until it meets a wall. he lets a lesser-known detail take a quiet seat beside the loom. Polarization distances measuring where the starlight's polarization angle or strength changes along a line of sight can pinpoint the first aligned grains, and therefore the approximate front face of a cloud, adding a sharp thread to the broader weave that extinction alone provides. Polarization lays the magnetic grain of the wall into the map, not just its mass. In these reconstructions, the cavity becomes an object in motion rather than a static whole. Young clusters arrayed on the shell carry ages that increase with distance from the cavity's centre. Their birthplaces projected onto the dust surface sketch outward growth, consistent with multiple ancient shocks and winds. The wall itself in some directions shows an opening that leans upward toward the galactic halo, a low-density chimney where dust thins into a broad throat. Corridors in the plane connect to neighbouring room seams where shells press and overlap. The picture is not a circle, it is an eggshell with cracks and doors, and the sun sits within it like a lamp near the middle of a thin, uneven lantern. Dry observations place themselves like small pins in a charcoal drawing. They call these maps images, yet every pixel is a solution to an inverse problem, not a photograph. The beauty belongs to arithmetic, not to lenses. They call the wall a line on plots, yet the plots hide thickness, dozens of light years of layered filaments that a single contour cannot confess. They call the progress sudden, yet the method is patience, decades of catalogues, calibration of colours into dust and distances that teach the sky to step forward. He lets the imagery stay elemental so the geometry remains breathable. Dust is the memory of pressure written into a rind. Gas is the breath that fills and then yields. Light is the tracer that accepts subtraction with humility. Extinction measured as colour excess becomes contour. Reddening gradients become slopes, and where slopes steepen filaments are implied belts within belts, some curling into dense cores where molecules hide and stars begin. Ages of clusters along the wall place themselves like small lamps turned on at known times. Their distribution tells of expansion rates measured not by clocks at the edge but by children's birthdays on its fate. Put together, the dust surface and the newborn's ages say supernovae acted as gentler architects pushing the shell outward, so that it gathered the very clouds that later kindled without claiming sole authorship for any star. The mystery that remains is appropriately sized for a living map. How complete the reconstructions are where bright nearby stars are scarce. How much the conversion from reddening to dust mass varies with grain properties along different arms of the wall. How finely the shell's true corrugations can be recovered when the loom's warp and weft sight lines still leave gaps. All are questions answered in ranges, not edges. Dust to gas ratios differ slightly from filament to filament. Extinction curves tilt depending on grain growth and shattering histories. Magnetic fields thread some ridges like rails and cross others like stitches. Each variation adds a quiet uncertainty to the final relief. He allows one gentle analogy that does not carry more weight than it should. The maps are like a topographic model of a coastline made from tide marks left on rock. Each line is truthful and incomplete, and only when many tides have passed does the shoreline declare itself. The reconstructions do not merely outline a wall, they also time it. By comparing the positions of young associations along the shell with their independent ages, the wall's growth acquires a cadence a few million years between successive arcs in some directions, longer in others, as if the rim's expansion met denser gas here and thinner there. Kinematics from gas surveys, neutral hydrogen and carbon monoxide agree, showing velocity shifted just enough to suggest outward motion. In a few places, the geometry becomes generous enough to see curvature directly arcs that bend on the sky and in depth assemble into bowls, star-forming chains. Perseus, Taurus, Chamaeleon, Lupus sit on these bowls' lips like dew on a rim. A quieter detail settles near the edge of the page, the long-old idea of a Gould belt, an inclined ring of nearby star formation, softens in these data into a projection effect, many of its ring-like features explained as perspectives on the local bubble's shell, rather than a separate tilted structure. The belt becomes a fold in a lantern, not an object with its own spine. 3 soft ironies take their seats and do not move. Only took subtracting starlight to draw darkness into a shape everyone can point to. Only required the faintest reddening in millions of spectra to pull an eggshell out of noise, an object bigger than every story people have told. Only needed children on the rim, young stars with ages barely into the millions, to become clocks for an expansion seeded by deaths long finished. The maps help the smaller bubble make sense of itself. As the heliosphere's boundaries lean and swell under external pressure, and the local field's direction, the reconstructed wall and its nearby filaments constrain that field's orientation and the density gradients that set the scale of the heliosphere's asymmetry. The lantern takes its cues from the lantern it sits within. Polarization on the wall aligns with the field that also threads the cloudlets the sun now crosses. Where the field bends along the rind, the thread's field likely bends too. Even the chimney's openness matters. A path to the halo allows venting that can reduce pressure locally, giving the heliosphere a slightly longer reach in that direction. He returns to the craft of the maps so the science can remain anchored. Bayesian inversions enforce smoothness, where data are sparse, and allow structure where stars are dense. Priors keep the solution from inventing cliffs. Later releases fold in new parallaxes and revised photometric 0 points. Each update moves some surfaces by a few parsecs, sharpens filaments, and resolves bifurcations that earlier grids had smeared. Cross-checks with radio data fix places where dust implies gas, and gas confirms dust. Ultraviolet absorption lines against bright early-type stars provide pencil tests through the wall components in sodium and calcium that sit at distances consistent with the dust front. Where each method overlaps, confidence rises. Where gaps persist, the maps say not yet without pretending otherwise. A small, clear, so all a mystery, remains visible by design. The degree to which the local bubble connects to loopway and other super bubbles through tunnel-like corridors remains under active reweaving. Some maps show narrow saddles, others broader overlaps. The truth is likely porous, a network of rooms whose doors do not stay shut. As data improve, corridors sharpen or soften by a few tens of parsecs. A reminder that rooms in gas are arguments settled by pressure, not by plan. He lays 3 more dry observations like calm stones. They call expansion fast, yet measured rates of a few kilometers per second take millions of years to move a wall by the width of a single long sightline. They call the chimney an opening, as if a vent cut yesterday, yet its throat is as old as the shell around it and broadens by inches in galactic terms. They call the wall complete, yet every new catalogue adds stars where none had distances before, and the relief wrinkles another millimetre closer to its truth. The mood returns to patience. The sun drifts within a cavity traced by subtracted light. The wall writes newborn ages along its inside face. The chimney tilts upward, into the halo like a slow plume, seen in relief. Corridors stitch our roomed neighbours, and the heliosphere arranges itself to these quiet facts without fuss. The maps are true in the way that living things are true, they change when fed. He closes the section by letting the accepted fact, the lesser detail, the mystery, and the ironies settle where they began. Fact: 3-dimensional dust reconstructions tied to distances and colours outline an irregular shell around the sun and time its outward growth through the ages of stars born upon it. Detail polarization, distances and angles add magnetic grain to that surface, placing the first aligned dust precisely along some lines of sight. Mystery completeness corridors and conversions from reddening to mass keep their ranges and refuse to pretend to be points. Irony's darkness mapped by subtraction youth, dating an old Ipanmon slow motion measured better than fast. The room continues to be woven from starlight, and the planet beneath that starlight continues to turn unnoticed by the loom, and content to be held by a shape it cannot see. He tips the room upward until it thins into sky, because the cavity is not a sealed jar but a basin with a throat. The accepted fact sits quietly and holds the view steady toward high galactic latitudes. The local bubble opens into the halo through a broad, low-density conduit, often called the local chimney, where dust and neutral gas fall away, and hot tenuous plasma and magnetic field lines have a path from the disk into the space above. The opening is not a circular vent, but an irregular boulevard stitched from gaps in dust and hydrogen, bordered by filaments that curve like ribs. Through it, the bubbles after heat and the galaxy's larger fountain meet. He lets the geometry arrange itself softly. Dust maps made from colours and distances show column densities sinking toward the pole. Neutral hydrogen surveys echo the decline with a trough in brightness. Soft X-ray maps brighten along the same direction when the sun's variable foreground is accounted for, as if a skylight had been lifted in the lantern's top. Polarization angles lean with the ascent, hinting that the local magnetic field does not lie flat on the disk, but inclines upward, guiding the slow drift of heat and momentum into the halo. The wall, which elsewhere looks like a contoured ridge here, becomes a shoulder that falls away, a slope laid open to sky. A lesser-known detail takes its place without insistence along some sightlines near the opening. Ultraviolet absorption from O6 ions that live most readily at a few 100,000 Kelvin appears against bright background stars, a pencil-thin taste of interface layers, where hot gas from the cavity meets cooler material in the halo. The lines are narrow, faint, and enough to say that the throat is not empty air, but a corridor of mixing skins that convert heat into light. He keeps the picture balanced in scale and tone. The chimney is one path among many in the disk-halo exchange, a local example of a general practice clustered star formation and supernovae in the disk heat gas that rises buoyantly or is pushed upward by pressure cools as it expands and later rains back as high-latitude clouds or faint drizzles along field-guided channels. The local bubble, born of deaths in nearby associations, participates by offering a ready-made route. Its internal pressure in earlier epochs was surely higher, its interior hotter, its wall younger and more sharply defined so that upwelling flowed more freely. Now the opening remains a relic throat where present flows are quieter but still oriented. The mystery remains honest and small. How continuous the conduit is open all the way into the halo at most longitudes, or braided with partial partitions that make cul-de-sacs. How thick the mixing layers run. How much of the soft X-ray brightness along the ascent belongs to hot gas in the throat, and how much to the solar wind charge exchange that foregrounds every line of sight these stayers ranges. Not statements, because the maps are stitched from subtraction and the sky refuses a single exposure. Dry observations take their seats and say no more than needed. They call it a chimney, as if masonry, yet the boundaries are gradients and folds, not bricks. The opening is drawn by absences, not by edges. They call it a vent, as if wind, yet the flows are slow and rarefied atoms per cubic centimetre, crossing vomes measured in hundreds of light-years more circulation than draft. They call it local, as if narrow, yet its throat spans tens of degrees on the sky and reaches into the same halo that receives fountains from arms half a galaxy away. He keeps the imagery elemental so the physics can exhale. dust along the ascent thins like breath leaving a window. Gas transitions from warm and partly ionized to hotter and more tenuous. Field lines lift and curve, tracing lanes that charged particles prefer. Light changes species, ultraviolet absorption for interfaces, soft X-rays for hot interiors, faint HA for skins, where recombination can still whisper. In that shift nearby, high-latitude windows become practical GIFs lines of sight with such low galactic foreground that observers point through them to count galaxies and weigh cosmic backgrounds. The chimney doubles as a laboratory and a peephole, a place where the galaxy is transparent not because nothing is there, but because what is there is thin, hot, and honest. He allows one gentle analogy and then lets it fade. The opening is like a thermal above a quiet plain, a slow upward door where warmed air glides. The plane here is the disk, the warmth, the memory of supernovae, the gliding. Not a motion one could feel, but an accounting the halo keeps in ions and faint light. Along its rim, the bubble's wall changes behaviour. Where curvature faces upward, compression focuses. Where the VOPE breaks, filaments bead and align. In some longitudes, the chimney's shoulder hosts clouds whose skins are sculpted by radiation from young stars on the rim, and those skins can act as shadows against the soft X-ray sea, proving by absence that brightness sits behind them, not always in front. Shadowing experiments placing dense nearby clouds against the sky and comparing counts across their faces have become a quiet craft. They say where glow is local and where it is behind the curtain. Toward the chimney, the glow is often behind. A quieter detail settles near the floor of the throat, the so-called Lockman hole, an especially low column of neutral hydrogen near the North Galactic Pole has served for decades as a window to the distant universe. It too lies within the larger breezeway, and while it is not the chimney itself, it is kin to the same sculpting, a patch where the disk's gas shies away and the sky lifts. He returns to the way the small bubble inside the large hears the throat's geometry. The heliosphere's reach can lengthen slightly where external pressure softens along the ascent. The direction of the interstellar magnetic field draped by the same filaments that border the opening inclines. The heliopause accordingly. Neutral helium flowing from the local cloud enters that region as faithfully as elsewhere, but the distant maps that rely on low dust to see extragalactic targets prefer these high latitudes. In this arrangement, a boundary of particles responds to a boundary of gas and dust, and a boundary of sight takes advantage of both. 3 new ironies settle without asking for notice. Only took removing what blocks light to learn more about what the galaxy contains, as if ignorance were cleared by absence. Only required hot gas too thin to touch to connect the disk to the halo with a structure large enough to earn a name. Only needed the memory of old explosions to arrange a modern convenience, a window through which telescopes look out and in looking out also learn the shape of home. He keeps the chimney's kin in view because context is a way of breathing. Adjacent super bubbles. Loop I and others press against the local bubble's wall. Along their seams, the geometry bulges and narrows, making corridors that join rooms. Some of these corridors tilt toward the halo. Others lie in the plane and carry gas sideways to denser districts. The chimney is one limb in this porous network, not a singular event. Its openness waxes and wanes with where pressure finds a path, where fields admit or resist, and where new generations of stars add or withdraw momentum. The present arrangement is a photograph of a moving conversation. He does not force a verdict on scale. The opening is many hundreds of light years long in practical terms, because the notion of into the halo is not a gate but a slow thinning. Its width on the sky is wide enough that no single cloud can close it. Its floor is structured by filaments that thread the rim and continue upward like stair rails. Its ceiling is the place where naming a ceiling becomes an act of taste, not of measurement. The galaxy above is already here. He rests once more on the small puzzle. How much of the soft X-ray brightness along the ascent is truly interior to the local bubble, and how much resides in layered plasma in the lower halo? How connected the throat is to chimneys that exit other superbubbles? How often material falling back from the halo high-velocity clouds, thin and cold, threads these openings to rejoin the disk? Each question has partial answers, and maps that change by degrees when new stars are folded into distance catalogues. The chimney survives every update, even if its edges shift and its railings change angle. Dry observations take their last places like stones beside a path thinning into heather. They call it a single conduit, yet porosity is the rule, and many small openings make one broad impression. They call it a blowout, yet blowouts were yesterday. Today's flow is a whisper laid across an old route. They call it a discovery, yet observers have peered through these windows for decades. Naming simply catches up to practice. He lets the section close where upward becomes outward. The cavity holds a door to the halo. Dust falls away along that door. Hot plasma and magnetic lines lean into it. Ultraviolet ions mark skins where temperatures step down. Soft X-rays fill the background once the sun's breath is subtracted. Radio quietens, extragalactic sky brightens. The fact sits where it was placed. An open corridor above us links our local room to the galaxy's larger circulation. The lesser detail keeps its calm. 06, along the ascent, tastes the interface and proves the corridor is not silence but a layered conversation. The mystery stays in right proportion, continuity, partition, and the balance of foregrounds. The ironies rest where they lie. The room is not closed. The lantern breathes